In these questions, we have to apply the concepts of sum and difference of cubes. Let's write down the formula first. Right. So it's quite easy to remember the formula. If you observe, there's a pattern in the formula. If you have a cubed plus b cubed, and then the next term will be a plus b, right? So you will have plus positive positive followed by negative and then positive. So it's plus plus minus plus. But if you start off with a cubed minus b cubed, if you start off with a negative, then you will have a negative, negative, positive, positive, right? So it's plus plus minus plus or minus minus plus plus. All right, let's look at part C. Wait, for this questions also, that's another 3 more formulas that these 3 are the algebraic identities that we'll be using later. So I may as well write it down first. All right, so for a relatively difficult questions like 6C, I would suggest that you use substitution. So we can let x plus y equals to a, then x minus y equals to b. Right, so what we are factorizing is a cubed plus b cubed. Okay, I'm sorry, a cubed minus b cubed. We are factorizing a cubed minus b cubed. So we'll be using the second one, that is the difference of cubes. So that will be equals to a minus b followed by a squared. So it's negative, negative, positive, positive. All right. But remember the substitution, a and b is just the substituted values for x plus y and x minus y. Right. So the next step is that we can write down the original values that you're given. I'm sorry, not values, the original expression you're given. Okay. It's very, very important that you bracket all this. It may look a bit daunting, but don't worry. If you were to do the factorization carefully, right, the final answer is a rather simplified one. Right, just have to watch out for this. That's the reason why I said you have to put the brackets there. Okay, this one here, we can use this algebraic identity. And that will give me x squared minus y squared. It will be x squared minus 2xy plus y squared. Let's close it. Okay, let's simplify further. So the first term, x minus x, will be gone. Y plus y will give me 2y. Okay, that's a lot of terms on the second factor. So what I would suggest that after you have dealt with the term, just put a tick. So let's say x squared with another x squared and with another x squared. So that will give me 3x squared. So I put a tick on top of the x squared. That is to tell me that I've already dealt with it. Then the next term that I'm going to do manage is 2xy. So 2xy minus 2xy give you 0. Okay, and then I will have y squared minus y squared. That will give me 0. And then the last term is another y squared. So this will be your answer. Okay. Alright, part 1 we will need to apply the difference of cubes. So let's write down the formula to factorize a cube minus b cube. That will give us a minus b, and then a squared plus ab, then plus b squared. Okay, minus minus plus plus. Right, let's look at part 1. Right, so if you were to look at the formula that I've written on your right hand side, you have to express it in terms of to the power 3, in terms of cube. What you are given here is x to the power of 6. So how do I write it in terms of cube? Likewise for 64, we have to write it in terms of cube. Okay, it's very important to express whatever numbers or whatever variables you're given to express it in terms of cube, because the formula that we are dealing it here, it's called the difference of cubes, right? So what do I put in here? It's x to the power of 2. Why is it x to the power of 2? Because here, if you were to recall, there's this rule that we learned, okay, that will give us m times n. So 2 times 3 will give us 6. Right, so 64 can be written as 4 cubed. Okay. Right. So if you find it a bit confusing, what I would suggest is let's try to use substitution. That means we're going to let a equals to x squared, b equals to 4, and then let's write down the formula. So the formula will be a minus b, a squared plus ab plus b squared. Okay, the next step is let's substitute the values of a to be x squared. Substitute the values of b to be 4. Alright, so let's simplify. Now, so x squared minus 4, you can further factorize it to be x plus 2 and x minus 2. And this one, you can simplify it to be x to the power of 4 plus 4x squared plus 16. Okay, right. So this portion here is important. If you have trouble managing variables, like you can just use the substitution method. Substitution method, it's a very useful method for you to try to break the problem into bite size. Okay, so that's part 1. Right, so how about part 2? Hence, to find the values of x for which. So what we are dealing with in Sec 7 Part 2 is to solve an equation. So to solve an equation means we have to find the values of x. So we have already factorized x to the power of 6 minus 64 in Part 1. So I can replace it with what we have found earlier. So this one here, I can replace it with what we found here, which I'm going to use an x3, okay, x3 to represent it. Right, so let's write down. That will give us x plus 2, x minus 2, x to the power of 4 plus 4x squared plus 16, and that is equals to x squared plus 4 to the power of 2 minus 4x squared. Alright. Okay, so we can okay, so there's actually nothing much you can do on the left hand side, right? It's already factorized completely. However, on the right hand side you can still expand this. So this is exactly what I'm going to do. Okay, so I'm going to use this algebraic identity. Okay, to expand this one I've just underlined. So that will give us x squared to the power of 2 plus 2 bracket x squared 4 plus 4 squared, then minus 4x squared. Alright, so that simplify further, that will give us x to the power of 4 plus 8x squared plus 16 minus 4x squared, and they give us x to the power of 4 plus 4x squared plus 16. Okay, now look at it very carefully. On the left, and then look at it also on the right. Can you see that there's something common there? Right, so we're going to bring everything to the left hand side, and we're going to factorize the one that have underlined, the factors have underlined in red. So we're going to do it at the next slide. Alright, let's continue from part 1. Right, so we're going to bring everything to the left hand side. So you would end up getting x plus 2, x minus 2 with x to the power of 4 plus 4x squared plus 16 minus, okay, I have to remind you to bracket this term when you bring over from the right hand side to the left hand side. Right, so if you want to do algebraic manipulation well, then you have to pay a lot of respect to brackets and to the sign. Okay, the next step is I'm going to factorize x to the power of 4, because that is the common factor. So what I'm left is this. Alright, so from here I can apply the zero product rule, which means you would have x to the power of 4 plus 4x squared plus 16 equals to 0. Okay, wait, I think I'll write it here. Have x to the power of 4 plus 4x squared plus 16 equals to 0, or x plus 2, x minus 2 minus 1 equals to 0. Right, this one is easier to manage, so we're just going to solve it Right, so let's try to expand this again, and that will give us x squared, a plus b times a minus b. All right, recall that a plus b with the a minus b, right, it will gives you a squared minus b squared. So it gives you x squared minus 4 minus away 1 equals to 0, and hence you will have x squared equals to 5. So x can be positive or negative square root 5. Right, so this is all right, this is easy. Difficult one is this. I'm going to put 2 asterisk here, which I'm going to continue here. All right, so far what we have learned is even if you use discriminants or quadratic formula, they're mainly to manage quadratic equations, a quadratic polynomial, right? So what we're going to do is we're going to rewrite x to the power 4 as a quadratic format. And here I'm going to use substitution. Right, remember we said that substitution is a very useful method. I'm going to let x squared equals to a. So you would get a squared plus 4a plus 16 equals to 0. Okay, so we're going to find the values for your discriminant b squared minus 4ac. And you will end up getting a negative 48. And negative 48 is less than 0, which means that this equation, a squared plus 4a plus 16, has no real roots. Right, so if there's no real values for a, obviously there's no real values for x squared. Right, so hence x to the power 4 plus 4x squared plus 16 equals to 0 has no real roots. So therefore, the only solutions are x equals to positive or negative square root 5. So far, we have only learned 2 theorems, a remainder theorem and factor theorem in polynomials. So if it's not factor theorem, then it has to be remainder theorem. So part 1, we need to show that 2x plus 1 is a factor. Right, so if you're using factor theorem, if 2x plus 1 is a factor, we need to show that the remainder is equals to 0. So let's start by writing the dividend. 2x cubed minus x squared plus 3x plus 2 is a dividend, equals to 2x plus 1. This is your divisor, multiply with the quotient plus remainder. Right, so our aim is to show that the remainder is 0. Right, so how do we show that? We let 2x plus 1 equals to 0. So we are substituting negative half for x. Right, so on the left hand side we would have, substitute all your x with negative half, and the right hand side will be just the remainder that we need to find. Right, so therefore remainder, just use your calculator to evaluate all the numbers on the left hand side. Right, you will have, if you use a calculator correctly, you should get 0. Right, so how do you explain? We don't just leave answer as, therefore remainder equals 0. We need to have a concluding statement. So the concluding statement is, since remainder equals to 0, using factor theorem, two x plus 1 is a factor of 2x cubed minus x squared plus 3x plus 2. Usually for this sort of questions, part 1 and part 2 are related. Let's try to expand the right hand side and let's see what happens. You can use the distributive law to expand it. If you were to bring everything to the left hand side, and simplify it, you bring everything to the left hand side and simplify it, you end up getting the polynomial that you're given in 9 part 1. And what have we shown in 9 part 1? We've shown that 2x plus 1 is a factor. Right, so we have to find the remaining factors. So how do we find the remaining factors? There are two ways of doing it. You can either use the long division. In this case here, your 2x plus 1 will be your divisor and you find your quotient. Another way is use compare coefficient of similar terms on both sides. Right, so I'm going to use long division. Wait, hang on, I think I made a mistake here. So multiply with x. Alright, so what we have will be 2x plus 1 multiplied with the quotient, which is x squared minus x plus 2 equals to 0. Alright, so the question is asked to show that the equation has only one real root. That gives you a hint that the real root will have to come from this factor 2x plus 1. So in other words, this quotient here will have no real roots. Okay, so there are two ways of doing it. Either use a quadratic formula to show that there's no real solutions, therefore no real root, or you can actually use discriminant, find the values of b squared minus 4ac and show that it has a negative value. Alright, so this is what we're going to do. The next step is to apply the zero product rule. So 2x plus 1 is equals to 0, hence you get x equals to negative half, or x squared minus x plus 2 equals to 0. Right, so I'm going to use discriminant because it's easier. And you end up getting 1 minus 8 negative 7, which is less than 0. Alright, so you can make a conclusion. You can say that since, alright, x squared minus x Alright, I don't think I have space to write it here. Okay, so the concluding statement is that since b squared minus 4ac is less than 0, okay, because negative 7 is less than 0, alright, so x squared minus x plus 2 equals to 0 has no real root. So hence x equals to negative half. Alright, you finish it on your own. X equals to negative half. It's the only one real root for the given equation. The first part of the question requires us to solve the equation. That is a cubic equation. So to solve for cubic equations, we have to find a factor. We're going to use a calculator to help us find the roots of this cubic equation. If you use your calculator correctly, you will get x1 equals to negative 3, x2 equals to negative half, right? So this is the cubic equation. Why is it that we only have two real roots? It is possible because one of them could be a repeated real roots. Means your curve okay, right? So x equals to negative half. It's the repeated roots here. So what we're going to do is we're going to give your cubic polynomial a name. We're going to let it be called fx. I'm going to let x equals to negative 3. So f of negative 3 will be 0. It makes sense that the remainder is 0 because x equals to negative 3 is the root of your cubic equation. Hence, you should not have any remainder. So therefore, x plus 3 is a factor. To find the other factors, you can use long division, which is what I'm going to do it here. Right, so we would end up having x plus 3, and the quotients that we get is 4x squared plus 4x plus 1, and that must be equal to 0. Because we're solving an equation, so we have to let it equal to 0. From here, we can try to factorize your 4x squared plus 4x plus 1 into 2x plus 1 bracket 2x plus 1. And we can apply the zero product rule, which will give us x plus 3 equals to 0. Right, you can see that 2x plus 1 is a repeated root. So your answers are x equals to negative 3, or x equals to negative half, and x equals to negative half is actually a repeated root. Part 1 and Part 2 are related. We have already solved the equation in Part 1, where our solutions are x equals to negative 3, or x equals to negative half. X equals to negative half is the repeated roots. So for Part 2, we would have to make use of the answers that we have obtained in Part 1. So how do we make use of it? Right, let's examine what we are given here in part 2. Now, if you were to compare with what you are given in part 1, you would observe that the coefficient, okay, the coefficients of the variables are the same. That means the coefficient of x cubed is 4, right? And the coefficient of x to the power of 6 is also 4. So what I'm going to do is I'm going to underline for you. Right, can you see that the coefficients, and then the coefficients of x squared is 16, the coefficient of x to the power of 4 is 16, coefficient of x is 13, coefficient of x squared is 13, and then the constant is also the same, positive 3. So what we are going to do is we're going to leave this coefficient alone. We're not going to touch it because it's the same. The constant also, we're not going to touch it. So what we're going to do is that we're going to rewrite our x to the power of 6 as power of 3, as power of 3. Because part 1, if you look at part 1, we're dealing with 4x cubed. So how do I rewrite it? I would have to express x to the power of 6 as x to the power of 2, then bracket to the power of 3. I'm actually applying this rule that you learn in the rule of indices, in the chapter indices. You learn all these rules, and one of them is this. So I'm actually applying this one here. Likewise, for x to the power of 4, I can write it as x to the power of 2. Okay, the next step is I am going to use substitution method. I'm going to let x squared equals to a. I'm going to replace x squared with the letter a. And let's see what happened to your equation. You would get 4a cubed plus 16a squared plus 13a plus 3 equals to 0. So can you see now that what we have obtained here is an equation that we're given in part 1. And in part 1, what are the answers that we have got for x? Because the answers that we've got for x would be the answer that we're going to be used for the variable a, right? So can we say that a is equals to negative 3? Or a is equals to negative half? Yes, we can say that. But what exactly is a? A is actually a substituted value for x squared. So I have to put back my x squared into a. So when a is equals to negative 3, we're saying x squared is equals to negative 3. Or x squared is equals to negative half. Right. So in this case here, to find the values of x, we would have to square root a negative 3, square root a negative half, which it will not give us the real values. Okay, square root of negative 3 and square root of negative half will not give us a real value. Therefore, we can conclude that there are no real roots to the equations given. There are no real roots to the equation given in part 2. We are given two curves here. This one is a cubic curve. This is a cubic curve. and this is a quadratic curve. If you were to take negative x and multiply it with your positive 5x, you will end up getting negative 5x squared. And since the coefficient of x squared is negative 5, what you're having here is an N-shaped quadratic curve. So roughly, if you were to sketch both curves, it may look like this. You have a cubic curve and then a N-shaped curve. So this a quadratic and your cubic curve will intersect at the 2 points there. Right, and we have to find the coordinates of these 2 intersection points. So how do we go about finding the coordinates of these 2 intersection points? We would have to solve these 2 equations simultaneously. And since both curves are already expressed in terms of y, we can just let 2x cubed equals to the quadratic curve. The next step is we're going to use distributive law to expand the right hand side. If you were to bring everything to your left hand side, what you're getting is actually a cubic equation. And how do you go about solving a cubic equation? We have to find one factor. And how do you go about finding one factor? You can use a calculator to help you find the roots of your cubic equation. If you use a calculator correctly, you would get x1 equals to 3 over 2 and x2 equals to negative 2. So why is it that there are only 2 values of x? Now, for a cubic equation, these are the three scenarios. You can have 3 real roots. Right, you can have 1 real here, this is 1 real, and 2 real and repeated. So basically you still have 3 roots, it's just that one of them is repeated. Then of course, the last possibility is no real roots for this part of the curve here. That means you only have 1 real root. That's all for the third possibility. Right, so judging from what we get for the values of x, most likely it's this situation here where one of the roots is repeated. First thing first, we're going to give a name to our cubic polynomial. We're going to call it fx. And then I'm going to let x equals to negative 2. And I'm going to sub x to be negative 2. So when I sub x to be negative 2, obviously my remainder is 0. I have to get remainder 0 because x equals to negative 2 is the roots of your cubic equation. So therefore, x plus 2 is a factor. The next question is, how do you find the remaining factors? You can either use long division or use compare coefficient of similar terms to find the other factors. Here I'm going to use long division. Alright, you should get remainder equals to 0 because x plus 2 is a factor. If you do not get remainder equals to 0, means you have made some calculations in your long division. So you have to check your working. Right, I'm going to erase all this to make space for my remaining workings. So this is what I'll get. And I will have to factorize this. Right, so I'm going to apply the zero product rule. So x plus 2 equals to 0. 2x minus 3 equals to 0. X plus 2 equals to 0. Right, so can you see that x equals to negative 2 is repeated? So this is what I mentioned just now, that x equals to 3 over 2 is one real root, and x equals to negative 2 is the repeated one. We can't just stop at finding the x coordinates of the point, because the questions require you to find the coordinates of the points. So what does this word points means to you? It means that a point has x and y coordinate. So it is not enough just to find the x coordinate. We still have to find the y coordinate. So how do we go about finding the y coordinate? Now, these two intersection points lie on the cubic curve. It also lies on the quadratic curve. So it's easier that I substitute into your cubic curve to find your y coordinate. So I'm going to sub x equals to 3 over 2 into y equals to 2x cubed. Likewise, substitute x equals to negative 2 into your cubic curve. Right, so how do you present your answer? Since the question asks for the coordinates of the points, we would just answer by saying, therefore, the points are 3 over 2, 27 over 4, and negative 2, negative 16.